Good morning, everybody. Another screencast video tutorial, SAT type question. You can follow me on Twitter at @dmoraine. Visit my blog Math Notations, and you can see these videos on YouTube on my channel Dave Moraine, formerly known as Math Notations Vids. You can just type that into the search engine for YouTube, Dave Moraine. Anyway, here's a problem that is similar to the kinds of coordinate problems that are asked on the harder SAT questions. It could be a multiple choice or a grid-in. I'm going to leave this as a grid-in. And no choices. So we have the graph of a quadratic function, x equals y squared minus 16, intersects the axes at 3 points. Find the area of the resulting triangle. Now, students might not be as comfortable with the quadratic functions of the form x equals as opposed to y equals, but regardless of whether they have a lot of comfort with this type of question or these kinds of functions or not, they need to understand that it is not necessary to draw the graph or even know exactly what the parabola looks like. In fact, the parabola looks something like this. Very rough sketch. It's a rotated parabola because it's of the form x equals. But a more important approach here is to understand that the points where the graph crosses the x and y axes are easily obtained from the intercept method. First, we'll determine the values of x where y equals 0. And from the equation, when y equals 0, we have x equals 0 squared minus 16. So x equals negative 16. That would correspond to this point here at negative 16. When x equals 0, we would have 0 equals y squared minus 16, which leads to 2 points at 4 and negative 4. We want the area of the triangle formed by these 3 points. So, using area equals half the base times the height, using this as the base, half the base would be 4 units. The height would be 16, so we get 64. How would you rate this question? Very difficult. Level 5, highest difficulty. Level 4, level 3. I would say this type of question would normally be among the last 5 questions on an SAT section, standardized test section. Students are probably less familiar with this type of question, therefore it would be considered more difficult, but they should feel comfortable with using intercepts, replacing x or y by 0, and even if they could not draw the picture of the parabola, they only needed the 3 points to make the triangle. Perhaps an extension of this, a little more challenging, would be x equals y squared minus k. Determine the area of the resulting triangle. This would be multiple choice, since the answer would depend on the value of k. It would in fact be a function of k, and k would be known as a parameter. Some of these types of questions are appearing more frequently on standardized tests. Using the same approach, we could say when y is 0, x is negative k. And when x is 0, we would get y equals plus or minus radical k. Again, the area being 1/2 base times height would be, of course, depending on the value of k. And we'll assume for this problem that k is positive. Otherwise, we'd have some complications and require absolute values. At any rate, the area would be half the base times the height again, so we would get k times radical k. Don't forget that condition. I overlooked that, but we threw it in. So that would be a little more sophisticated. Problems like this are appearing more frequently. Students need a lot of experience with it. It would be great if these kinds of questions appeared in textbooks so that students would not feel as if they're seeing it for the first time. Coordinate problems, the geometry algebra connection, and functions and graphs are becoming commonplace in the curriculum for the Common Core. Thank you.